In this video, I'm going to explain how to use the Graft, Flatten and Simplify tools to control your data structures in Grasshopper. To follow along, you can download the template files in the link below. Graft, Flatten and Simplify are three of the most commonly used tools to manipulate data structures in Grasshopper. Knowing when to use each is critical to controlling how your data passes between each component. Let's take a look at each of them. Let's take a look at the Graft tool in Grasshopper. To put it simply, grafting creates a new branch for every item. Let's head over to our Grasshopper party and look at two scenarios where we would use graft. In this first scenario, imagine this group of people were a list that we wanted to graft. If we were to graft this list, each of these people would be placed on their own individual branch and would have their own path counting up from 0. They would also become item 0 in their own list on a new branch. In this second scenario, imagine this group of people at the party were organized into a tree based on the degree they were studying and the university they went to. If we were to graft this tree, the logic is the same. Each person would be placed on their own individual branch. An extra path would be added to their existing notation, so they will now have 4 paths which represent the party as the main branch, the uni as the sub-branch, the degree they're studying as the sub-sub-branch, and the person as the sub-sub-sub-branch. Let's move over to Grasshopper and examine this in practice. In this first example, I have a flat list of random points on one branch notated as 0, 0. If I right-click, I can select the graph shortcut. Each point is now placed on its own branch, and an extra branch is added to the notation, starting at 0 and counting up to 35. In this second example, we have a grid of points, which has 6 branches and 6 items on each branch. If I right-click and select the graph shortcut, each item is again placed onto its own branch, and a branch notation is added to the end of each branch. This time, they only count up based on their initial branches, so from 0 to 5, as they're nested branches within the original structure of the grid of points. So that's how they work, but when do you need to use this in Grasshopper? Typically, there are 2 reasons why we would graft. The first is to match the branches of another tree. In this example, I have a collection of straight curves that have been divided into points, and each point has moved outwards based on its proximity to an attractor curve, which are then transformed back to curves using the interpolate curve component. I want to loft these curves to create some fins like an architectural facade. If I plug my starting straight curves into this merge component and also plug in my new curves, you'll see that I don't get the fins I'm looking for. Why not? If we create a parameter viewer, we can see that our straight curves are coming in as a list on branch 0, and then our new curves are all on their own branches. So our loft works on each branch and lofts all the straight curves, but then can't loft anything else because each subsequent branch only has one curve. We need to make these 2 groups of curves match. So let's graft our straight curves, and then we'll have 2 data trees that match. So now each straight curve will be on the same branch as its corresponding curve, and we're able to loft. The second reason to graft is to match the items of another tree. In this scenario, I have a first grid of rectangular curves that is scaled at 50% to create a second grid of smaller rectangular curves. I want to loft each rectangle with a corresponding smaller one to create a series of window-like openings. My scale output and my curve output are both matching data structures. They're flat lists with the same lengths. So if I plug them into the merge component, my loft should work, right? Wrong, because our items are 2 lists, they both merge into one long list, and then the loft tries to run through each curve one by one. If we graft our scale output, and also graft our curve output, this puts each item on their own branch. These branches will then both match up, and we'll end up with 2 curves on each branch in our merged list, which contains a larger and a smaller rectangle. So now when we loft, we get the windows that we were looking for. Next, let's take a look at the Flatten tool in Grasshopper. Flattening is quite simple. It removes all branches in a data structure and puts everything onto a flat list. Let's head back to our Grasshopper party and look at how this works. Imagine our group of partygoers were once again organized into a tree based on the degree they were studying and the university they went to. Flattening removes all of these branches and puts everyone back onto a list. Our index count starts at 0 and counts all the way up. No matter how complex your data structure or how many branches, flattening will always remove all branches and give you a flat list. Let's move back to Grasshopper and examine this in practice. I have a square grid with 20 branches and 20 items on each branch. If I right click and select Flatten, you will see I now have a data tree with all 400 items on one branch, so our data structure is gone. So when should you use this? Flattening is really helpful when you want to use your data as a singular list. In this example, I have a grid of squares that form the basis for an attractor point algorithm. I am measuring the distance from the center point of each square back to an attractor point and then creating a scale factor based on this distance. If I plug my cell output, my centroids, and my map numbers into the scale component, I'll get an attractor pattern. But it doesn't look quite right. Each row in my grid is scaling by the same amount. That's because my grid is a data tree, so I'm creating a scaling value that gets applied to each row only in this grid. What I really want is a scale for each square. If I flatten my starting cell output, I'll remove the data structure that is interfering with my scaling, and I'll get a flat list that scales at each square location. Next, let's take a look at the Simplify tool in Grasshopper. Simplifying essentially removes redundant overlap shared amongst all branches. At our Grasshopper party, you would have noticed all these extra zeros in our data tree. Grasshopper adds these when our data transforms into something else, and these can grow out of control if we're not careful. Simplifying lets us remove all these overlapping redundant branches that contain these zeros. So it's like removing our party goers from the Grasshopper party and just categorizing them into the degrees they're studying. In Grasshopper, I have a grid of rectangles with 3 levels of branch notation. If I right click and simplify these, the first 2 zeros are removed and only the branches that are creating splits remain. So when would you use Simplify? I would recommend using Simplify in 2 scenarios. The first is when you have complex data structures that have 5 or 6 levels of notations that are collections of zeros or overlapping branches. And the second would be when you want to match data trees. So let's look at an example of this. I have a data tree of straight lines all on one branch. At the top here, I found the start and end points of each line, moved them out from these points, and drawn a line between these points. Below this, I'm finding the intersecting points between our straight lines and a NURBS curve. I'm then moving these out from their starting point and drawing a line between these points. What I'm trying to do is create a series of facade fins that lofts these top set of lines with this middle set of lines with this bottom set of lines. Let's plug these into our merge component in this order. So it hasn't worked, and why not? I'm going to create a parameter viewer for each of these line outputs. Notice how our middle set of curves have an extra branch notation. When plugged into our merge component, our data trees do not match as a result. We can see this with the parameter viewer in our merge output. But we can fix this by simplifying the output of each line component and removing all this redundant branch data. And now our trees match up and we can see our fins. When operating on data structures, it's always important to use Graft, Flatten and Simplify to help restructure your trees and organize your Grasshopper data. This video is part of a longer data structures in Grasshopper course available on thedifferentdesign.com. So if you want to keep learning, sign up for an account with us today.